Central Station Fire Control System permits the placing of sighting stations and gun turrets at the most effective locations for each. With the sighting station and gun turret located apart from each other, the electric control causes the guns to follow automatically the gunner's line of sight. Here in this picture, the basic circuits of the electric control will be developed and their operation explained. Power for operation is taken from the plane's direct current supply. The Central Station Fire Control System consists of the sighting station, gun turret, servo-amplifier, dynamotor, and amplidyne generators for elevation and azimuth. Each amplidyne generator is driven by a motor. When the field of the generator is excited, a direct current voltage is produced in the armature. The dynamotor, driven by the plane's power, generates the alternating current required for control of the system. An understanding of alternating current, or AC, is important to the explanation of this system. When an AC generator is running with the external circuit open, no work is being done. Current does not flow. However, voltage or pressure is present. This voltage has an alternating polarity and changes as the generator rotates. Now, if a load is put across the line, current flows. Current flows from positive to negative, and thus will reverse its direction of flow as the polarity of the voltage changes. The polarity of this alternating voltage is important in considering the direction of travel of the gun. This alternating voltage is applied to the Selsyn transmitter on the sighting station. When the sight and guns are in alignment, as indicated by the arrows, there is no signal voltage from the Selsyn receiver on the turret. When the sight is moved, say to point below the guns, the signal voltage that appears at the receiver output will have the same polarity as the input voltage to the transmitter. Note these relative polarities. If the sight is pointed above the guns, the relation of these polarities to each other changes. Note these polarities. The signal from the receiver ultimately causes the guns and Selsyn receiver to be driven into alignment with the sight and Selsyn transmitter. Selsyn units are represented as a single winding or rotor, which can be turned, and a triple winding or stator, which is stationary. The AC supply to the transmitter rotor induces voltages into the stator, which are carried through wires to the stator of the receiver on the turret. These voltages represent the sight position. When sight and guns are aligned, no voltage is induced from the receiver stator into the receiver rotor. Moving the sight changes the voltages across the wires between the transmitter and receiver. And now a signal voltage induced into the receiver rotor is sent to the servo-amplifier. From the polarity of this signal, the servo-amplifier determines the direction in which to drive the gun. The servo-amplifier provides two identical control channels, azimuth and elevation. Only one channel is necessary to explain the operation. This channel includes a power supply transformer used for both channels, a signal input transformer, and two electronic or vacuum tubes, represented by these symbols. The three principal elements of a vacuum tube are the plate or anode, the control grid, and cathode. The filament is used only to heat the cathode. With the plate positive, the control grid positive, and the cathode negative, the tube acts, in effect, as a closed switch between the plate and the cathode and permits current to flow. Any other combination of polarities will cause the tube to act, in effect, as an open switch. No current flows. However, we have seen that current will flow when the plate is positive, the grid positive, and the cathode negative. The transformers and tubes are connected into the system with the Selsyn transmitter, Selsyn receiver, amplidyne generator, turret drive motor, and dynamotor. The DC power supply continuously drives both the amplidyne generator and the dynamotor, and also excites the field of the turret motor. The dynamotor furnishes AC to the power supply transformer, which then excites the tube plates. AC is also supplied to the Selsyn transmitter, which in turn sends a signal to the receiver. Now, in order to trace the action of the circuit, let's stop the alternation with the plates of the tubes positive and the cathodes negative. Starting at the Selsyn transmitter, we see that with the sight and guns in alignment, no signal goes out from the Selsyn receiver on the turret. When the sight is moved, a signal voltage from the Selsyn receiver is sent to the primary of the input transformer in the amplifier. This transformer divides and proportions the signal voltage for application to the vacuum tube grid. Note the polarities of the voltages on the grid. The grid of the upper tube is negative. Therefore, the upper tube acts, in effect, like an open switch. The grid of the lower tube is positive, and with the plate positive, this tube acts, in effect, like a closed switch. Now, current can flow from the positive end of the transformer secondary winding through the tube, the lower field coil of the amplidyne generator, and back to the negative end of the transformer winding. The flow of current through the lower amplidyne field coil produces a DC voltage within the amplidyne generator. which sends a current through the turret drive motor armature. The rotation of the motor drives the guns and receiver toward alignment with the sight and transmitter. As the guns line up with the sight, the signal and control voltages fade away. The turret stops. With no signal applied to the grids, the tubes pass small equal currents. The effects of these currents are canceled out within the generator field winding. The guns are now in alignment with the sight. A movement of the sight in the opposite direction reverses the polarity of the signal voltages. This changes the polarities on the grids of the tube. And now, the upper tube acts in effect as a closed switch, passing current from the transformer through the upper amplidyne field coil. The resulting amplidyne voltage is reversed. The turret motor rotates in the opposite direction. And again, as the guns are driven into alignment with the sight, the operating signals fade away. In the basic circuit, one tube was shown for each direction of movement. Actually, two tubes in parallel are used. This is done in order to pass stronger currents through the amplidyne generator field coil. With a signal voltage applied to the grids of the tubes, the current will now flow through two parallel paths. Resuming the alternations of the AC supply, note that the current through the upper tubes flows only during the moments in which their plates are positive. This gives a pulsating current through the field coil, which is not desirable. A protective resistor and condenser connected across each field coil will charge and discharge with these pulsations, thus giving an effect of a steady current flow through the field coil. These condensers and resistors are located in the lower corner of the servo-amplifier. With the system as developed so far, the turret will follow the sighting station, but the action is not smooth. When the sight stops, the guns will not come to rest. This hunting motion is caused by a tendency of the turret to over-travel. Hence, the guns and receiver are driven back and forth across the position of alignment. This causes a reversing voltage to be applied to the turret. To show how this condition is eliminated, the diagram action is halted for a moment. A condenser and two resistors connected into the grid circuit now apply a voltage to the input transformer. This voltage opposes the signal voltage as the guns are driven into alignment. Note the opposing polarities. Resuming the diagram action, the turret now slows down as the guns approach final alignment. Over-travel is reduced. The turret is stabilized. Here we see the guns hunting. And now they are stabilized. 31-1 speed control is applied to both azimuth and elevation channels. The azimuth channel will be used for the explanation. To make the guns follow the sight accurately, A Selsyn transmitter on the sighting station is geared to the sight at a ratio of 31:1. A receiver on the turret is geared to the guns at this same ratio. Thus, one revolution of the sight turns the transmitter rotor 31 times. The guns and receiver follow likewise. With the power off, note that one turn of the sight will align the Selsyn transmitter and receiver 31 times. Now, moving the sight, then switching on the power, the receiver is driven into the nearest alignment with the transmitter. But the turret is not driven far enough to line up the guns with the sight. A further motion of the sight will be followed by the turret, but with the same misalignment between sight and gun. To avoid this, another Selsyn transmitter is geared to the sight at a ratio of 1:1. And another receiver is geared to the guns at the same ratio. These Selsyn units take control of the system during large misalignments. Wires connect these one-speed units in the same manner as the 31-speed units. Again, with the power off, the sight is moved. Switching on the power, the guns are now driven until both Selsyn receivers are aligned with their respective transmitters. The guns and sight are now in alignment. The one-speed signal is amplified by the signal input transformer, a double vacuum tube, condenser, output transformer, and 2 neon lamps. These parts, the one-speed Selsyn units, input transformer, double vacuum tube, condenser, output transformer, and 2 neon lamps, are wired into a circuit. This circuit is applied to the system by connecting the amplified output to the grids of the main tube. Resistors in the 31-speed circuit permit transfer of control. Power for the one-speed amplifier is taken from another secondary winding on the power supply transformer. Now, moving the sight, a signal voltage is applied to the grids of the vacuum tube. Note the polarity. The lower half of the tube passes current through part of the primary of the output transformer, inducing a voltage into the secondary winding, connected between the 2 neon lamps. At low voltages, these lamps act as open switches. As the misalignment between the sight and guns increases, the voltage on the neon lamps also increases to a point where the lamps break down, act as closed switches. Now, the output transformer voltage is applied directly to the main grid circuit, overpowering the 31-speed signal and assuming complete control of the system. As the turret is driven toward alignment, the voltage on the neon lamps decreases. The lamps cut off, and the 31-speed signal resumes control to bring the guns into exact alignment with the sight. With the power off, the sight may be moved to any position. The turret will not follow. Switching on the power, the one-speed takes control. Approaching alignment, the one-speed control cuts off, leaving the 31-speed to drive the guns into final alignment. This cycle of action is called synchronizing. The main tubes are designed with additional grids used to control the characteristics of the tube. These screen grids are connected into the system through a double vacuum tube used as a simple rectifier, a resistor, and a power supply transformer secondary winding. The cathode heaters for all 6 vacuum tubes in each channel are connected in parallel to an additional secondary winding on the power supply transformer. This same winding, together with a potentiometer connected into the cathode circuit of the main tube, provides an adjustment for balancing the action of the upper tube against the lower tube. This is the only adjustment within the servo-amplifier. Resistors are connected into the circuit to protect the tube grid and to control the bias voltage on the cathodes of the tube. And now, with the circuits completed, we see why any motion of the sight is faithfully followed by the gun.